So what we have here is a question that relates to circles and properties of circles. This comes from paper 2 of the 2019 higher paper and is question 15 in that paper. So we're given a diagram here with a circle and various bits of information on it. We're told the circle has a centre at C and it has a point P which lies on the circle as shown. I want to find the equation of the tangent at P for this circle. That's the first part. Second part looks at getting the equation of another circle in relation to the information we've got here. Let's focus on part A first. Now, key bit of information we need to remember is that for a straight line, we need a gradient and we need a point. We can't get the gradient of P. Yeah, point T is marked on here, but we don't know it yet. We need the equation of the line to be able to calculate T. We're not given it. However, what we can do is use the property that the tangent to a circle is perpendicular to the radius of the circle at the point at which it touches. So you could imagine that's my radius of my circle. I know that the tangent and that radius are perpendicular to one another. So because that's the case, I can use the property that m1 times m2 is equal to -1 for perpendicular lines. So if I calculate the gradient of this, use this property, I can use that to then work ahead and get my straight line equation. So what I'm going to do is calculate my m1, my gradient there. So I'm going to do 13 take away 12 over 5 take away 8. So 13 take away 12 is 1, 5 take away 8 is -3. So it's -1/3. So the equation then of the tangent, I'm going to use the fact that m1 times m2 is -1. So the equation then of my tangent, m2, is equal to 3. So the equation of the tangent of the line is equal to 3. Then I want the equation of that line. So I'm going to use y minus b equals m bracket x minus a, and the a and b come from a point on the line, which in this case is going to be p. So I'm going to say fine, so that's y minus 13 is equal to 3 bracket x minus 5. Then multiply out the brackets and we'll simplify it down a bit. So I get y is equal to 3x, so that's then going to be minus 15, but I'm then adding 13 on, so that's going to be minus 2. So there you go, equation of the tangent, y equals 3x minus 2. If we then look at part B, so part 1, wants me to state the coordinates of t, but if we look before it, the tangent from P meets the y-axis at the point T. So I have to state the coordinates of that. Now state means you should be able to read it off straight away. Now I know that the point T is on the y-axis, so straight away I can say fine, on the y-axis, x is always 0. I then need to figure out the y-intercept. Well, if I look at the equation of the straight line, your y-intercept is this part here, so it's at -2, so the coordinate of t is 0, -2. Job done. Second part is find the equation of the circle that passes through the points C, P, and T. So for the equation of the circle that passes through the points C, P, and T, what I need to do is find firstly my diameter. So the diameter is going to run from C all the way to T. And then I have to use that to get all the information I need for the circle. So I need a midpoint of the circle, and you need the length of the diameter of the circle, which I can then get to get the radius, or just the radius on its own. And then I can get my equation of my circle from that. So if I've made that there my diameter, the point C to T, I can get my midpoint, let's call that MP, by finding the middle of that line. So if I find the middle of the x's and the middle of the y's, I'll find it. So my x's, I'm at 0 and then 8, so the middle of that is 4. And for my y's, I'm at -2 and I'm at 12. So if I add them together, divide it by 2, I get a midpoint at 5. So for my circle, that there is going to be the centre at 4, 5. What I then need to do is find my radius. Now the radius is the length from either T to the centre, the midpoint to C, or the length of T to C, then halved. So what I'm going to do is I'm going to do the length from T to the centre. So the radius is going to be given by the square root 4 minus 0 squared plus 5 take away -2 squared. So the difference in each of those. So what that then means is it's going to be the square root of 4 squared, which is 16, plus, well, 5 minus minus 2, so that's 5 plus 2 is 7. 7 squared is 49. So my radius is going to be equal to root 65. Now we know for the equation of a circle, it's given by x minus a squared plus y minus b squared equals r squared, and for that a and b are the centre, r, well, it's the radius itself there. So given all this information I've got here, the midpoint, the radius, what I can quite simply say is that the equation of my circle is going to be x minus 4 squared plus y minus 5 squared equals 65. There you go, the equation of the circle that goes through the points C, P, and T. So answering that part of the question there. So for this one, there's a few marks available. Part 1 has 3 marks available for it. So first mark comes in from finding this first gradient here between the 2 points. Second one comes from using the properties to find the gradient of the second part. And then third one comes from getting to the equation of the straight line itself. B part 1 is worth a single mark just for stating that point. And then B part 2, another 3 mark one. You get 1 point for the centre, 1 point for the radius, and 1 point for the final solution. Now this radius here, root 65, can be implied from this. So if you don't exclusively write it down, but you get to this stage, they'll look at that implication of r squared 65, so r is root 65, and they'll give you that second mark from that as well. Get in a habit though of just writing everything down. Make sure you show them where everything's coming from and how you've got to it, so they didn't take any marks off you. So there you go, working with circles and the properties of them. Make sure you go away, you understand each of these properties and how they relate to one another, and the relationship between tangents and circles, centres, diameters, etc., and how to work with them from there.